Okay, we have this question now, sine cubed, cosine to the power 4. Since we have trig, yeah, raised to a power, I suspect chapter 7.2, which is what? Trigonometric integrals. Yeah. Of course, since I have a trigonometric integral, I'm going to use identities. Yeah, like what? The identity I'm going to use is something like sine x squared plus cosine x squared equals 1. Yeah, this is the identity I'm going to use since I have sines and cosines. All right, let's see. We had cases. We said that if sine and cosine are multiplied with each other, you take the one that is odd and separate one of them and use the identity. Yeah? So let's do that. Don't get scared of this. This is gonna matter by the end. Yeah? But, when I'm integrating anyway. So now I separate one. So it's gonna be the integral. Sine, I separated one, 2 over 3 x. Sine squared 2 over x, 2 over 3, sorry, x, multiplied by cosine to the power 4, 2 over 3 x dx. So now I'm going to use an identity on this one. What is the identity I'm going to use? I'm going to basically throw sine to the other side here. So it's going to be the integral of sine 2 over 3x multiplied by this, which is going to be what? 1 minus cosine squared 2 over x, 2 over, I'm insisting, 2 over, yeah, this is the one, yeah, multiplied by cosine to the power 4, 2 over 3x dx. So now what do? Now I'm gonna substitute. Let u equals cosine 2 over 3x. du is going to be what? Minus sine 2 over 3x multiplied by what? The angle, right? The differentiation of the angle, chain rule, yeah? 2 over 3. Yes. So now I noticed that I have everything. I have the sine here, but what I don't have is the resulting minus 2 over 3, this minus and the 2 over 3. So I'll have to multiply by 1, which is equal to 1, to what? Equals to 2 over 3 minus multiplied by minus 3 over 2. This gives me 1, so I did nothing but a trick to integrate. So I'll multiply outside by minus 3 over 2 and inside by minus 2 over 3, so I could basically integrate peacefully. And I could turn the whole integral in terms of u. So the integral now will be, this is a part of my derivation, this is a part of my derivative, basically this one, and this is a part of my derivative, so it's going to be du at the end. Yeah, so du accounts for sine 2 over 3x, this one, and the number minus 2 over 3 and dx, since they all are here in my derivation. So it's going to be what? 1 minus cosine, right? This is cosine, so it's going to be u squared. And outside I have this entity, which is going to be u to the power 4 because it's cosine as well. So now this is my integral multiplied by minus 3 over 2. I'll deal with it later. So we'll multiply these basically to become a very simple integral. We could solve easily. U to the power 4 minus u to the power 6, because when we multiply, we add the powers. du. I integrate normally, like I'm integrating anything else. So it's going to be u to the power 4 plus 1 is 5 over 5 minus u to the power 6 plus 1, which is u to the power 7 over 7 plus c. Now you back substitute. You just plug everything where it should be. Minus 3 over 2 multiplied by cosine 2 over 3x to the power 5 over 5 minus cosine to the power 7 2 over 3x over 7 plus c, and that is the solution to your integral. But again, why did I use this method of 7.2? Because I have a trigonometric function raised to a power and they're multiplied by each other. They both have an angle, which all complicates matters if I want to use any other method. You cannot use by parts because they're the same family. You cannot use, you'd use substitutions only because there are powers here. Yeah? So the easiest method to do this is by 7.2's method, which is basically consisting of this. We studied this in part 3, where if the power is even or odd, they each have their own cases. But in this case, you take the one that is odd, which is sine in our case, and you separate one and use the trigonometric identity, and afterwards use the right substitution. And this is the